Thank you. So today I will talk about image processing happening on server side. My name is Emil Lerner. I play CTFs with Bushwhacker's team. Occasionally I do security research and I validate the importance of this research via bug hunting. So assume we have a website that allows users to upload some multimedia. For example, an avatar, it could be a cloud drive along to store multimedia files, and it processes it on the server side, generating image previews. For an attacker, it presents a complicated attack surface. So we have some complicated binary input, which is the image. We have some open source library running as a server, because no one would code the image processing themselves. And we have a direct output channel, the preview from this library, because no matter how many levels of abstractions is present, the output, the preview will be generated by the library itself. The topic is far from being new, starting from image trading in 2016. It gained a lot of attention, a lot of different libraries were hacked, but the attack surface, the attack vector still persists, and the attack surface is still not espoused. Today I will mostly focus on vector graphics. So the most popular vector format is obviously SVG. It's a XML-based vector image format. It has a lot of implementations, a lot of different libraries. And what's important for today's talk, it supports including raster images. So most of security research of SVG focused on including external images. However, today I will talk about including inline images, the images that are inlined to an SVG. So what we do when we attack an image converter? First thing, we need to understand which exact library is running at the server side. So if we do this with generic libraries like ImageMagick, Pillow, maybe Java libraries, we can upload a picture that is processed differently by different libraries. So, for example, this would happen if we upload a GIF image that does not contain any palette. And we will see default palette for this library, which is black for ImageMagick, this gray thing for Pillow, and this colorful stuff for Java. We can use the same approach to detect which library converts SVG as a server side. And it's even easier because there is variety of different text, variety of different quirks. So, for example, we can take an SVG that includes 3 raster images. One is just basic PNG image. Another is a PCX image, which is uncommon nowadays. And another is just a PNG image, but included via path tag instead of the standard ref tag. And we will see that different libraries convert this image differently. So ImageMagic's parser is most permissive. It would allow everything. librsvg would ignore unknown format. And Inkscape, which is another popular server-side conversion library, would draw this red X, which is pretty unique to Inkscape. So if you see this, you will immediately know that it's Inkscape that is used as a server-side. So today I will describe one of the bugs I found in librsvg. And, well, generally librsvg is a good library. It's written in Rust. The code is pretty solid. It doesn't have that much of security vulnerabilities. I know there was another one, but it's pretty solid. However, it used to depend on another library named libgdk-pixbuff for raster images. It is not the case in the latest version. In the latest version, it's just clear Rust version. However, it used to use bindings to load a C library. And libgdk-pixbuff is a different story. It's written in C, the code is pretty messy, and it has a long history of memory safety issues. So it's pretty good target for an attacker. So one of types of memory safety issues I like the most to exploit is information leak via uninitialized memory. So it is easy to exploit at bug bounties because it does not require any system knowledge, any binary knowledge. How does it work? So assume we have some server process. Naturally, it works with some sensitive data, and it allocates memory for this data, stores the data there, and then frees this memory. No sane memory allocator would zero out memory after a free. So it may happen that the buggy library, the library that uses memory for image processing, would allocate the same memory block, and the bug is the library won't overwrite it before using. So it would use the same memory block for image processing and generate a preview containing the data that was in the newly allocated memory block. And it might be sensitive data. Then attacker would see the preview, download it, and recover the data. However, an important prerequisite here is the vulnerable library must be directly linked into the same system-level process as the sensitive information is processed in. If it is another process, a launcher, external command executed, there won't be any impact. But as we would see, sometimes the vulnerable library is loaded directly in the same system level, probably Linux level, process as the sensitive data is processed in. And I want to share a trick how to find these bugs. So the correct way to find this kind of bugs is using memory sanitizer, which is a great tool. It is included in all C-Lang installations, and it's pretty solid. I suggest using it. However, it has some pitfalls. It requires recompiling, and not only recompiling the library itself, but also dependencies with the MSAN memory sanitizer. So instead, we can have this little trick. We can write a simple malloc wrapper that fills the newly allocated memory with a particular byte value. And then we check if the output depends on this byte value. So normally, the contents of newly allocated memory should not be reflected in the preview, right? However, if we see that the preview depends on this value, we know that somehow we would be able to recover it because it contained in the preview. So it's a pretty simple trick. It requires you having a corpus of images to test on, but it does not require to recompile the libraries, the dependencies, and so on. Okay, the issue itself I found in librsvg is pretty simple, pretty trivial. So you include a BMP image, which is not that popular format nowadays, but it's an image format. And you truncate the image, leaving the only header. You fake the content type, replacing it with PNG, and that's it. The buffer will be allocated and then used for generating the preview. However, it would be never filled, never overwritten. So if some data stored there, the attacker would be able to see this via the preview. The first thing I did after detecting this bug, I immediately uploaded to all the bug bounties, especially to cloud drives, and the Microsoft OneDrive appeared to be vulnerable. So you see a lot of different previews. However, the uploaded image is the same. So you know that probably if you see different previews for the same payload, you know that something happening on the server side, and you can recover this data. And especially presentful is this case, where you can see some other user's document in your preview. So some other user was using OneDrive at the same time as I was attacking it, and their document were stored in the memory, and then this memory block were used for my image processing, and then I just saw the document, and because the width of the preview is the same for all users, I naturally can just read it. So this red censorship is added by me because by the nature of the vulnerability, I do not control which exact data I would leak. So I don't want to be an asshole and compromise this client. However, you can see that this is a real document. So you can extract real other users' data. Another interesting case was BaseCamp bug bounty. So BaseCamp is company invented Ruby on Rails, so it's not a surprise. They're running it, they're using it. And after I uploaded my vector as an avatar there, I immediately noticed that there is a lot of interesting data that could be recovered from the previews, including other users' cookies. So I got that it is some web server process. Another interesting thing at BaseCamp was fighting JPEG lossy conversion. So the previews were only in JPEG format. And JPEG is a lossy format. You can't just recover the original data from it. However, I used SVG filters to overcome this limitation. And SVG supports so-called table filters. When you provide a table of 256 values that are just substituted for each value of each channel. So channel is red, green, blue. And you have just a table that for each value you substitute another value. And the thing is, you can have multiple such filters and insert the same data with multiple filters. And then you have enough data to recover the original values, which could be AWS keys. So after uploading about 1 million images, uploading, recovering the data, uploading again, recovering, after 1 million iterations, I got this part. This is obviously part of some configuration file. And, well, it contained AWS keys, which were usable from the outside of BaseCamp network. So I guess it's another vulnerability, it's another misconfiguration that I could use it from my IP address. And it's not at the slides, but, well, these keys allowed me to access their S3 buckets that contained all the files ever uploaded to BaseCamp, which is like pretty huge compromise. Okay, so next popular image format is PostScript. So PostScript has different approach from SVG. SVG is the descriptive format where you describe what you want to see, and PostScript is an actual programming language when you describe how to draw what you want to see. It's an actual programming language for printers. And the thing is that printers are usually used to interpret So at the server side, the most common interpreter is GhostScript. GhostScript is a software, it's not a printer, obviously. It is executed at the server side to process PostScript files. And the thing with GhostScript is that it is extremely vulnerable program. It has a lot of vulnerabilities. So naturally, GhostScript has a sandbox for untrusted programs. And untrusted programs for printers should not execute system commands, should not access system files, and they have some GhostScript level sandbox for it. However, it is so many bypasses of this sandbox that it even doesn't make sense to talk about any of them. It's the difference, the trivial, memory safety, logical issues, so many of them. I personally found like 3 bypasses, so it's easy target to hack. GhostScript is basically RC as a service. If you see GhostScript is executed as a server side, you will probably get an RC. I guess every time I saw GhostScript was executed as a server side, I was able to get an RC. Maybe in a sandbox environment, but like I could actually execute commands every time, no matter what was the version. So initially I planned to demonstrate this GhostScript thing with another story from Dropbox. But then I thought maybe take something more recent, maybe take an example from 2025. For example, the website of Besides 2025. So let's see let's chain all the stages of the attack and see how the attack could happen. So yeah, we have a website. We have this nice talk. We are redirected to a third-party platform. Whatever, we'll hack this platform. And we can upload images. So the first thing we do is to upload this GIF image I talked about. So don't look at the PNG extension. It's actually a GIF image without any palette present in the image. So the format should have a palette, but there is no palette. And you see this black square. And now, from this black square, you know that it is ImageMagick probably running as a server-side. So the thing is, ImageMagick may support PostScript via executing GoScript. So what we do is we upload a PostScript file to check if this is the case. So the PostScript file would just print some random letters, but we see it printed, so we know that the GoScript, at least we know that PostScript files are processed at the server. So we can try something GoScript specific to check if it's a GoScript. So then we upload a file that just prints a GoScript version. Again, it's not an exploit, it's just prints something via preview. But now we know that it's GoScript running as a server-side, and it's pretty old version. So we can check the CVEs, we can find a CVE, we will develop an exploit. I will skip this part in the video, but we obviously can just find a proper CVE, develop an exploit, and then upload it. And then we would wait a little bit, and we get a back connect. Thank you. So we can naturally execute commands there. We see it's not that sandbox environment. Probably we could leak some data or modify it. And the other thing that you should note that on the left, you can see that the output of the commands could be printed directly in the preview. So, as I said, PostScript is a printer language. It can naturally print words. And if you have a command output inside a variable inside PostScript, you can naturally just print it at the screen. And it's really helpful in cases where the target do not have this internet connection. So you can explore the sandbox. Maybe you can bypass the sandbox. And that was actually the case at the Dropbox that I skipped. So I could upload a file, I could execute commands, I could evaluate the sandbox from inside it, and then I could bypass it executing commands as a system itself. Okay, so now let's move on to some takeaways for Blue Team. So what to do to protect yourself from these kind of vulnerabilities. And the thing is that like regular approach, just update everything to the latest version would not work. As you have seen, it's pretty easy to develop a zero-day if you have proper skills. So what you need to do is to put your image conversion into an isolated environment, into a sandbox environment. And isolated here means like really isolated. It should not have any infrastructure access. It should not have any network access, both to your internal resources and to the internet. And so it should be something like this. Even if you have like a worker that used solely for image conversion, probably it has access to some parts of your infrastructure. It could pull images from some kind of queue, process it, and then uploads as a result somewhere. So inside this worker, you should have something else. Probably a Docker container, and this should be a one-time Docker container. So it just converts one image and then it's destroyed. Probably it should have a read-only file system. So even if you have a separate part of your infrastructure solely for image conversion, inside this infrastructure you should have like really restricted sandbox environment. Yeah, basically that's it. We still have time for questions. Any questions? Yeah, go ahead. Yeah, I understand this, but well, in real life, you don't have that much image conversions, right? So you don't have those much avatar uploads. Usually you need to cache the result of the conversion. So you don't need that much resources. And if you see that pipeline is overloaded by someone, then you can, as usually you fight the DOS attacks, somehow you should fight them, right? You should have an ability to fight DOS attacks against heavy operations on your infrastructure, and that is just one of them, so yeah.
Is there any mitigation for the PostScript upload attack, aside from just not processing PostScript?
A good mitigation would be just disable PostScript processing. Yeah, that's correct. No one would upload PostScript as an avatar in real life. So that is what 90% of all bug bounty programs I reported this issue to they did this mitigation. However, as we thought, the issues could be discovered in different formats. It's not only PostScript. It could be in regular SVG processing pipeline. And for example, you may actually need SVG, not for avatars, but maybe for some reasons you may need SVGs. And so do what Google does. If you upload a PostScript file to Google Drive, it would be processed, and you could get an RC in this sandbox, but there is nothing there. It's impossible to get out of the sandbox. There is no sensitive data there, so it's not a security issue unless, attacker would mine bitcoins in this sandbox. So it's not a real security issue.
Have you been able to decode that data and identify its nature?
Yes, so obviously I did this with, you mean for OneDrive or for BaseCamp? For OneDrive, yes, I was able to, and so I learned that there is a Java process, .NET process that does only, sorry, not Java, obviously Microsoft, so they use .NET. So there is a separate .NET process that probably does solely image conversion, and I did not go beyond that. So I was able to cache some config files that's suggesting it was a .NET process, yeah. Okay, thank you very much. If you have any more questions, I'll be here. So, yeah, basically that's it. Thank you.